In this video, we're going to discuss the discriminant. What is the discriminant? The formula for the discriminant is whatever is underneath the square root sign in the quadratic formula, so that is b squared minus 4ac, because if you'll remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So the discriminant is this part of the quadratic formula. What can you use the discriminant for? The discriminant tells you how many roots and what type of roots your quadratic is going to have. If when you solve your equation for the discriminant, you get a positive answer, that's a perfect square, then your quadratic equation is going to have two real rational roots. Let's look at an example of this. Let's say we have the equation y is equal to x squared plus x minus 20, and let's solve for the discriminant. The discriminant would be b squared, so b is always the coefficient of the x term. The coefficient of the x term in this case is 1, so we're going to have 1 squared minus 4 times a, which in this case is 1, times c, which is in this case negative 20. The discriminant is 1 minus 4 times 1 times minus 20, which is positive 80. So 1 plus 80 is 81. Since 81 is a perfect square and it's positive, we're going to have two real rational roots. Let's see if that's true. Let's graph this on the calculator. We're going to graph y is equal to x squared plus x minus 20. And we can use Zoom 6 for Zoom standard. And we see that our parabola crosses the x-axis at two places, and we can have the calculator tell us if they're exactly on, it looks like it's going to be negative 5 and positive 4. We can have the calculator tell us. We're not going to spend time on it now. You can check it on your own using the calc menu. But this parabola does cross the x-axis exactly at x is equal to positive 4 and at x is equal to negative 5. The second scenario is when you have positive, your discriminant is positive, but it's not a perfect square. Then you're going to have two real irrational roots. Let's look at an example. Y is equal to x squared minus 13x minus 16. And let's find the discriminant. The discriminant is b squared, b in this case is negative 13, so negative 13 squared minus 4 times a, which in this case is 1, times c, which is negative 16. Let's just punch the whole thing straight into the calculator. Second quit. So we're going to do negative 13 squared minus 4 times 1 times negative 16, and enter. 233. Now you could try on your calculator, try to take the square root of 233, and you'll see that it is not a perfect square. So we are going to have two real irrational roots. And let's check that on the calculator. We're going to go into y equals. Let's graph it by y2 because I wrote in red. X squared minus 13x minus 16. And we could use Zoom 6. Zoom 6 only shows us one of our roots, so that means that our other root is somewhere out over here. So we're going to have to make our x max greater. Let's make it 25. Now we see both of our roots, and let's see if they're rational or irrational. They look like they sort of cross right on the lines, but we'll see from the calculator will tell us that they're really irrational. Second trace to get into the calc menu. down to 0. Enter. Now we need to find the left bound. We're going to start with the root on the left. So we moved our cursor somewhere all the way to the left of that point. And somewhere all the way to the right of the point, and then we're going to guess. Somewhere over here, enter. It tells us the 0 is negative 1.132169, and the decimal doesn't end there, it goes on forever. So this one, and if you try the other root, you'll see that it's also irrational. You can try it on your own, but this is also, the other root is also irrational. The third scenario you could have for your discriminant is when your discriminant is 0. When your discriminant is 0, you have a double root. A double root is when your parabola only crosses the x-axis at one place. Let's look at an example of that. Let's say we have y is equal to x squared minus 4x plus 4. And let's solve for the discriminant. The discriminant is, let's just rewrite what a discriminant is. It's b squared minus 4ac. So b in this case is negative 4. Negative 4 squared minus 4 times a in this case is 1 times c, which is 4. And the discriminant is equal to negative 4 squared is 16 minus 4 times 1 times 4 is negative 16. 16 minus 16 is 0. So this equation would have a double root. Let's look at that. Let's graph it. We're going to graph it in y3 because I wrote in black. So x squared minus 4x plus 4 and zoom 6 for zoom standard. And we see that it just touches the x-axis at that one place that x is equal to 2. The last scenario we could have, where we're using the discriminant, is the discriminant is negative. If the discriminant is negative, there are no real roots, which means the parabola does not cross the x-axis anywhere. There will be imaginary roots, but that's part of the Algebra 2 course, not the Algebra 1 course. So let's look at an example of that. Let's say we have y is equal to x squared minus 3x plus 16. And let's just remember the discriminant is b squared minus 4ac. And let's solve for the discriminant of this equation. The discriminant is b in this case is negative 3. So negative 3 squared minus 4 times a, which is 1, times c, which is 16. Let's just punch the whole thing into the calculator. Negative 3 squared minus 4 times 1 times 16, and that is negative 55. Since the discriminant is negative, this parabola will not cross the x-axis, and let's just look at that. Let's graph it. I'm going to graph it in y5 because I wrote in green. So this is x squared minus 3x plus 16, and we'll do zoom 6 for zoom standard. So we can't see it. That means that the graph is either too high up for us to see, it's over here, or it's too low down for us to see, it's over here. Let's try making our y max and our y min higher and lower respectively. The minimum will make negative 25, so we could see further down the graph. The maximum will make positive 25, so we could see further up the graph. And we see here that our parabola does not cross the x-axis. It keeps on going forever in the positive direction, keeps on going, but it's never going to go down again, so it will never cross the x-axis.